If this is a velocity versus time graph for an automobile accelerating from rest and going up through 3 gears, then what will the acceleration versus time graph look like, and what will the position versus time look like? In the first place, we can note that the total distance traveled, let's say this represents 20 seconds, 25 meters per second. Total distance traveled is going to be the area under the curve here, which will be approximately equal to the area under this trapezoid here. So we want to find the total distance. We might estimate that the velocity here is maybe 25 meters per second. Here maybe it's 5 meters per second. So that the average would be perhaps 15 meters per second times a 20-second time interval means there's a 300-yard distance here. Now, what does the acceleration versus time graph look like? Remember that acceleration is the rate at which velocity changes and is therefore going to be represented by the slope of this graph. What's happening to the slope? Well, we start out with a large slope and then the slope falls off to near zero. Then the slope increases again but then decreases back to near zero. Then it increases again but decreases back to near zero. And every time it starts the increase again, the rate of increase and the slope, therefore, is a little bit less than before. Well, what graph would show that? The graph would have to be a lot of acceleration here, then dropping off to very little, then more acceleration, then dropping off, then again greater acceleration, dropping off. Well, wouldn't that graph look something like this? Okay? As the slope levels off, the acceleration drops. Then the slope starts to increase again, so the acceleration turns around and increases up to a certain point, and then begins decreasing again. And similarly here. So maybe we'll get a graph that looks something like this. And the low point on the acceleration graph gets a little lower each time because our acceleration gets a little lower each time. The position versus time graph, if we think about it, let's say we divide this up into 4 increments, 5, 10, and 15 seconds. The area under the first increment is going to be smaller than the area under the second, which is smaller than the area under the third, which is smaller than the area under the fourth. Which means that we're covering more and more distance as time, per unit of time as time goes on. We cover more and more distance in each 5-second interval. This means that the graph of our position versus clock time will have an overall shape that looks something like this, increasing faster and faster, corresponding to the greater and greater areas that we sweep out as we move across the velocity time graph.